The only way you can prevent a bug to show up in production is by writing an automated test. That's it.
Mm-hmm.
It's not going to be gated anywhere. It won't be deployed to a staging environment. Either you write the automated test or you risk introducing a bug in production. And what the incentive structure that creates, you can probably guess, but we have incredible automated tests. Incredible. And that's what we wanted.
Welcome to Software Unscripted. I'm your host, Richard Feldman. Today I'm talking with Mike Bryzek, who's been a technical co-founder of two very successful companies using some very unorthodox technical strategies that have worked out really well for him and his teams. These include testing in production, spending the first few months of a brand new company's life investing in automation and tooling before shipping any product, and microservices, but not quite done in the way I've usually heard them described. I want to give a massive thank you to everyone who's been supporting Software Unscripted on Patreon. If you enjoy these episodes and you'd like to become a supporter too, check out patreon.com/softwareunscripted. And now, testing in production. All right, Mike, thanks for joining me.
Great to be here, Richard. Nice to see you again.
So you have a couple of, I'm going to say unorthodox or maybe unconventional positions on how to do software well. And you're also in the unusual position of having backed that up with two very, very successful companies that you built on these ideas. Or I guess in one case, you built it from the ground up on these ideas. And one was you sort of changed to it halfway through and it went so well, you did it again next time. One of which is testing in production. So you and I talked about like what you mean by that, but I'm actually kind of curious, how did you arrive at this idea of deciding to start testing in production?
That's a great question, Richard. And it is true. We do a ton of testing in production, and so much so that my kind of last business, we did away with test environments and staging environments and just relied on automated testing. But I think we'll come to that later in the episode.
Sure.
Back to, I think, my own experience in 2007 was the technical co-founder of an online fashion company called Gilt.com. Gilt grew very, very quickly. And by year 4, we probably had about 1,000 employees and several $100 million of revenue.
Yeah.
And an interesting thing happened, which is like it became really, really hard for us to build new software. And as we took a step back and looked at what was going on, there was a couple of dynamics. One was that as we thought about what we wanted to do, it took us a few months to find a team that had bandwidth to go work on the next product idea or feature. And by then the business priorities had shifted.
Mm-hmm.
And second, it was just taking us a lot of time to get things into production, a lot of churn, a lot of quality issues. We would take a long time to deploy, find errors in production, revisit, et cetera. So it just didn't feel that productive. And around the same time, we did something pretty interesting, which was we integrated with Facebook for social login. And this was probably around 2010, 2011, that era.
Okay.
And we had a really interesting observation, which was like, typically when we built our software, we deployed it to a staging environment. We tested it in a staging environment. Once QA passed, we then scheduled that release or that code to be part of a future release and eventually got released to production.
Mm-hmm.
So pretty, I think, traditional process for developing software. And when we were integrating with Facebook for social login, it was interesting because we weren't actually running Facebook's code in our staging environments, yet we were able to test against it. And when we dug into it, it's like, how is that possible? Well, it was possible because Facebook gave us staging accounts that we could test with. So instead of running their software, we were able to test in their production environment using these staging accounts.
Sure.
And that was like a really, really interesting kind of insight.
No, but I might think, I mean, at that point, that's certainly true for you, but I would assume that Facebook would have their own staging environments for, that they would deploy to before they would deploy the public facing thing that then you're able to test against, if that makes sense.
I don't know, but I do know since then there are many, many companies that offer kind of production and staging accounts in their production environment. Probably one of the most kind of successful would be Stripe. You just create an account in Stripe. It's clearly in their production environment. You can configure however you want. But I think the key thing that we kind of learned from that perspective was that there's different ways to to verify your software and minimize the chance of a defect in production. The second thing that happened around that time at Gilt is kind of when we looked at the process of software development, we saw a lot of centralized decision-making, kind of organized committees, which we work on next. How do we prioritize, centralized prioritization, centralized backlogs? And what we thought would be kind of interesting is to see if we can shift that and say, what if we actually just trusted the developers and create an environment where the developers could make good decisions, where the product owners on the teams could make good decisions about what to build, and then just trust those teams to go build those things themselves. And I think that insight of like, can we actually set up an environment where the technical teams themselves are trusted, both to make the decision as to essentially what to build and
Hmm.
how to build it and when to release it. What would that look like? And ultimately, that was the decision that led us down a path of what at Guild, what both became kind of a microservice architecture, but also this idea where we ended with a lot of testing happening only, I'd say only in production. It wasn't really true. But what was happening is we would go from kind of automated test to verification in production. But that key insight was like, how do you kind of invert the software developed delivery model so that teams could be empowered to figure out what's the best thing to build, make quick decisions, iterate on those decisions, and own those decisions and deliver them all the way to production.
Okay, so it sounds like it wasn't something that you had planned to try out, but rather you gave teams the autonomy to try out different strategies, and I guess in general to try to have a theme of sort of lowering the ceremony required to move from one stage to the next. And at some point, some team was like, hey, we're already testing against our production, Facebook accounts, but Facebook gave us these sort of fake accounts to test against. What if we just made our own fake accounts and just tested directly in production after running certain automated tests and stuff locally? Does that sound right?
Yeah, and we had a few things, interesting things happened. One was that the first problem that we ran into is that our teams couldn't actually deploy their software because it was like a
Mm.
monolithic stack, pretty traditional process. You deployed everything together. And it was manual. We had a manual deploy process. So the first thing we had to actually do was automate the deploy process, and that took us about 9 months to the point where we had
Wow.
kind of reliable delivery to production. Just automating the deployment process, and then the second thing that happened was, and then we saw teams still weren't deploying. And it's like, why aren't you deploying your software? They're like, well, we don't know if we're going to break something that we don't know about.
Right.
And it turns out that's a pretty deep problem. And the way that we kind of thought about how might we solve that problem was really to create isolation. Like, can you actually create a pretty strict boundary around where one piece of software starts and ends? Because if you can do that, then you can reason about just that piece of software and have confidence that something unrelated isn't going to break.
Right. Now
And that
this is
was
the part. So, I mean, this is the part where I would immediately say, okay, cool. Modules are the answer because modules are very cheap. They don't require spinning up any machines. They don't require any network latency. Um, and they allow you to isolate. And at least if you have a compiler that will enforce these things and not give you, loopholes that you have to worry about, they'll give you a way to say this piece of software begins and ends at this boundary. These are the functions that it exposes. Here's what you can and can't know about the data structures, etc. But that's not the direction you went in, to say the
Yeah.
least.
On a personal note, I'm a big fan of kind of modular design and modules and software. I think there's a lot of power and leverage there. I
Sure.
will say during this period of time in my own career, my favorite subject to read was psychology. I read all types of psychology books. Behavioral psychology was my favorite.
Uh huh.
And if there's one lesson to learn from that field, it's that the incentives really, really matter.
Totally.
And One of my favorite quotes is actually from Warren Buffett's partner, Charlie Munger. And he's famous for saying, show me the incentives and I'll show you the outcome.
Uh
And I think
huh.
it's just a really powerful way to envision this. And what I personally have seen in my career, both in my own companies and lots of friends in in industry, when I look at these modular monoliths, I find that the boundaries become hard to keep separate over any long period of time.
Hmm.
And I would say it's not for any error. I think everyone is trying to, generally speaking, everyone is trying to do a good job, build production quality code, not introduce defects. But over time, requirements change, times change, people change, and these boundaries get fuzzy. And the number of projects that I've personally seen where people start describing kind of these larger pieces of software as complex, tech debt ridden, hard to maintain, brittle. I think that's more the norm in our industry than the opposite. And
Yeah.
one of the real benefits of kind of really, if you kind of take a boundary and move it to, say, a microservice, you've made the boundary really clear and firm. And that boundary, what I've seen happen over time is that boundary tends to last a much, much longer period of time.
So I definitely understand the argument of like, yeah, this is like from an incentives perspective, it's really difficult to move that boundary once you've set it up. It's like, look, this is coupled to a machine, it's coupled to the network, etc. It's running in production. If you change it, there's consequences in production immediately, etc., etc. Uh, all those things make sense to me, but at the same time, I have to wonder if, and maybe this is, maybe there's some limit to how far you can go with the thing that has better technical considerations. Because I think we can both agree that if you can avoid introducing network latency in order to enforce a boundary and to solve an incentives problem, I mean, it's just technically better to not have the network latency if you don't actually need it for a technical reason. I assume we could agree on that.
Well, I
That
don't.
that's the downside.
Well, I don't think we're talking about introducing a network latency here because there's no reason that the separate services need to communicate with each other. And I think, but that
Oh,
starts
interesting.
taking us down a rabbit hole of like how do you
Okay.
design a microservice and where are the boundaries and what is kind of the bounded context and how you define that.
Okay.
I
Well,
am a
let's,
big,
yeah.
I am a big fan of very shallow kind of runtime call chains, and that was a lesson we learned at Guild, where over time as the microservices grew, we did have a lot of inter microservice communication, and
Interesting.
that is a challenge to manage. And the reason it's a challenge is like, let's say you measure 99th, your 99th percentile is pretty good. What that means is your 1 percentile, you don't really know what it is, but let's say it's
Hmm.
1 second, which is quite
Okay.
actually quite common in a lot of web apps.
Yeah.
If you get to a point where any individual user requests may touch 100 microservices, you're almost on average then going to find one of those 1 percentile requests, and your average response time starts really climbing. And
Okay.
once you
Yeah.
get into that environment, it's a really hard problem to solve. My second business, Flow, which when we built it, we kind of took everything we learned at Guild for microservices and these firm contracts. We built it in such a way that the call chain is really small. So you might have an authentication call and then the service call and then return to user, but typically we would rarely see any user requests hit more than 2 or 3 services.
So I wonder from an incentives perspective, like, what's the difference there? So on the one hand, again, I totally appreciate that the the boundary is a lot harder just innately. But on the other hand, it's like it seems like you had more success at the second company with addressing one of the traditional downsides of microservices, which is like total end-to-end latency that the end user experiences, um, by getting the team to architect things in a different way. But I agree with you, by the way, that it seems like in practice as an industry, we do have a lot of problems with using modules as an effective way to enforce boundaries. Like it seems like the incentive structure is such that if like all you have to do is add the pub keyword somewhere or add something to a list of exposing things, and
Yeah,
that's all the friction it takes to break the boundary, it's really easy for someone to do that, especially if you all have equal access across the code base and anyone on any team can just go in and add that one little keyword or that one little item in a list, and now all of a sudden the boundary is broken down. Whereas the only way to prevent it from being broken down is everyone has to not do that forever.
right,
I totally get
right.
that. But at the same time, I wonder if there's other, and I'm not trying to say you should have done this or shouldn't have done this, but like because there is that unavoidable, I'm just like I want so badly to like minimize the latency and like to try to solve the problem without in a way that doesn't um, introduce that. I have to wonder about, well, I'm sure one of the other things we'll talk about is automation. If there's some way to enforce that same kind of separation using just more hardcore automation, for example, let's say you have a huge team, you can have rules like only this team is allowed to make changes to these files in the code base. And therefore, if I want you to expose something else, I have to go ask you to make that commit on my behalf. At which point you might say, no, I'm not going to do that because that's going to break this, that, or the other thing. And I'm going to have to deal with the consequences.
That triggers in me the idea of ownership and how important
Okay.
ownership really is. Um, well, I would claim it's really important in the way kind of like we humans operate. And
Hmm.
one of the things that I really just love about having kind of these pieces of software, let's call them microservices. They may be large microservices, by the way, but these microservices are fully owned by their teams. Period.
Yeah.
100%. It is theirs. They own the functionality. They own the quality. They own the art. They own the way the code looks. They own lots of things, and we provide some structure as an organization around that to make it possible. But it's theirs. And one of the things that I've just seen is just like when people really take ownership, they do incredible things. And I think there's just a real power to that. A simple example for me, like one of the things, like I really pay attention to, let's say, things that frustrate me or irritate me in kind of the world and in my work. And I'll give you a really simple example of something that just irritates me as a professional software developer.
Sure.
Like, I don't like getting an alert that somebody else set up about my software. I don't like that
Interesting. Okay.
because I don't understand it. I don't have a kind of a deep appreciation for whether or not it's a valuable alert. I don't know if the group that set it up, I know they're well intentioned, but I don't know if they have the same tolerance for signal to noise as I do. And I'm
Hmm.
really sensitive to noise.
Yeah.
Um, and so, just as a general, like, that's just like a simple example. And for the projects that, like, where I'm on a team and our team fully owns the project, we also own all the monitoring and alerting. And when those monitors and alerts happen, we have both kind of the obligation to respond, but we also have the ability to tune the alert, disable the alert, adjust the frequency, change the alert, fix the code. We can do whatever we need to do so that we can keep the signal to noise ratio high, and own kind of the quality of the full software. And I think there's something there. I haven't really thought it through, and I personally, I haven't spent any time working on any huge kind of monoliths. So maybe these same dynamics can exist in that area where you feel that sense of ownership over your module. But certainly, I would expect that if I'm part of a monolith, I don't know that I have the authority to release the monolith.
Mm,
And so coming back again to kind of having full ownership and even making the decision as to when we release the software is really important. One of the reasons why is it important? Well, maybe our team doesn't want to get paged on a Friday afternoon and we decide we're not releasing Friday. Or maybe we have people in different time zones and so we're going to coordinate when we release, just in case that there's an unexpected surprise. We're all healthy, available, ready, expecting, as opposed to, say, somebody else chooses to release our software at a different time of day. An alert goes off, but we don't have the context that the software was just released. So I think there's something about just like kind of like almost the extreme ownership of the software that in itself ends up driving a lot of human behavior that leads to kind of ultimately all the outcomes that everyone is chasing: productive software development, quality software development, highly motivated people. You can even go further, longer retention within a company. I would
sure.
argue, I've seen in my own businesses. I've worked with people for like decades, and it's like, how does that happen? It's like,
Yeah.
wow, we're really proud of what we're building and we're having fun doing it.
Well, one of the things I'm really interested in is sort of whenever I find something that seems to be in practice working well, I want to try to break it down into pieces and try to understand which ingredients are essential to its success and which ones can
Yeah.
be played around with without sacrificing the success. So purely functional programming being a good example of this, where like I'm like, wow, I had a really great experience with Elm. I want to make this language that takes the Elm like experience that I love, but applies it to different domains than the ones that Elm is targeting. How can I do that in a way where I still feel like I'm getting the essential stuff that I love about Elm, even though it's a different language, and even as the language evolves in maybe different ways. Um, in other words, which parts are essential to the success, and which parts are like non-essential and or can be messed around with. And one of the things I wonder about with what you just said is a phrase I've heard in the context of microservices, which has always kind of rubbed me the wrong way, is regarding deploys. It's like, okay, deploys are maybe difficult. Like you said earlier, you had this symptom of like, it was really hard to get a deploy out the door and it took a long time and it took, only certain people knew how to do it. Not everybody knew how to do it, et cetera. And then the phrase that I've heard in the context of microservice advocacy is like, if it hurts, do it more. And I understand where that's coming from, in the sense of like, oh, well, if deployments are bad, then you should do more of them because that will naturally create an incentive for you to make the process better. But that just feels to me like the wrong way of looking at it. It's more like, well, if it hurts, that's a problem you can fix. Like if the deploys are taking too long and are too painful and are too like isolated in terms of who can do them, you can change that. You can make an investment so that deploys are easier, et cetera, which seems like the thing that you're supposed to conclude based on the do it more advice. But I would rather just go to the direct thing, which is, yeah, you can invest in automation and deploys. And the reason I bring this up is that what you were talking about like, let's say one team owns some piece of code and they want to control when it deploys. I'm reminded of another way that you could potentially look at something like deploys, which is traditionally those are done in terms of servers or services. And you're saying like these cluster machines are now running a new piece of code. But another way you could look at that is something along the lines of like hot code deploys, where you say like, well,
Mm-hmm.
each team is responsible for a certain set of modules. Those modules can be independently patched in and out and even rolled back in and out on a live running system across whatever cluster of machines are all running these things. I'm not saying that's easy, but it does seem like the type of thing where if in both cases you need a certain degree of automation and investment in tooling to make it possible, either in the microservices world or in the hot code loading hypothetical world that I don't know anyone's ever really nailed. I mean, I've heard like Erlang can theoretically do this, but I've also heard that when people do like hot code deploys in Erlang in practice, it's like they're very, very careful. They spend a lot of prep time and they, it's like a multi-day process of like, let's make sure this is going to work for sure and test that out really thoroughly, et cetera. So it doesn't sound like that's the like, just jam it into production, thing that we're talking about here. But again, I wonder, like, as with the module things, like, is there some other way that you could get that without having to go all the way to coupling it to services. I don't know. What do you think?
Well, I'm a big fan of, I think, with continuous delivery, and for context, when we set up the last business flow in 2015, like from day one, we were a continuously delivered microservice platform.
Right.
And one question just I often get is like, why would you choose to do that at a startup? Wouldn't it be better off just building kind of the monolith? And I would
Because you said
say,
it took like a couple months to set all that up, right?
yeah, we
At the get
probably,
go.
I probably personally spent the first 2 to 3 months of the business just making sure we had the right infrastructure and tooling in place to be able to do that. But the real reason why I chose to do that is that's how I knew how to build software. And so for me, it was a way of just taking technical risk off the table. We have enough business risk and market risk. Like, why learn a new way of building software? That's the way kind of I was productively building software at that moment in time. So just keep doing it.
Yeah.
Um, what I find like fascinating about continuous delivery, and in our definition, what that was as soon as you committed to main, that change was going to production in automated fashion. So it'd be in
Mhm.
production in a few minutes. And the typical workflow at the time we're using GitHub. So open a pull request, merge your pull request, and it's going to production.
Mhm.
And back to incentives, I want to come back to incentives, but there are no guardrails. It's up to the developer to open the pull request. They can merge the pull request right away. They can commit to main directly if they wanted. Entirely up to the developer to do those things. Um, what I find fascinating about when you really embrace continuous delivery in this way, like you will be deploying dozens of times a day yourself. And then put
Mhm.
yourself in the context of a group of people, you can be doing 50, 100, thousands of deploys a day. That's where you end up. But interestingly, like the goal of each deploy changes pretty fundamentally. And your goal of the deploy essentially isn't to not break production. Like you're not actually introducing necessarily new functionality at that point in time.
Mhm.
And then we start layering in. So then the big question becomes, well, how do you introduce a new feature? Well, I would argue the first thing you want to do is make sure that you didn't change the existing behavior in an unanticipated way. So that's step one. And in practice, what like that's a profound change, profound. And like as I remember working with lots of people throughout my career, and I remember in particular um, one engineer. We started working together. This was their first time working in a continuous delivery way, and we were following Scrum, so we get to our retro, and I asked the questions like, man, I'd love if each of us could go to bed with all our code in production. Like, what would it take to like not
Mhm.
allow a PR to last overnight?
Hmm.
And what we ended up discussing is like that's just a profoundly different way to work, and we need to start thinking about not just the end deliverable of what we're building, but like each individual like incremental milestone along the way. It's like very different.
Right. So when I've heard of, hey, as soon as it lands on main, that means it goes to production. There are definitely some loopholes that some companies I may or may not have worked for in the past might have used to get around that, such as, well, yes, when it goes to main, it goes to production, but the convention is when you open a PR, you open it against a different branch called like development or something like that, and then that gets QA'd, and then that gets promoted to production. But you're not only talking about PRs are made directly against main, or you can just push to main at your own discretion. But also, when you make a PR, you're supposed to leave it open for less than 1 day. Like you're not supposed to leave it open overnight. So you make the PR and it's like, cool, CI passes, ship it. That's it.
Yeah, and here I think is where we get into what I'd argue is some of the interesting psychology of all of this. And I'll make the claim: I'm like 100% convinced in my own career and the work over the last. It's been a while now. This leads to higher quality software. Period. Like
Okay.
the goal is high quality software in production. Like I don't know about quality software that's not running in production. Not interested in that. But if the goal is quality software in production, 100% this leads there. The why is like I think a little bit more kind of nuanced. Um, I think as a starting point, like when we think about developers, like I generally believe everyone I've kind of gotten the chance to work with in my career wants to do good work.
Hmm.
And we don't want to introduce bugs in production. That's not our goal. So we're all
Yeah.
working towards the same thing. And then from kind of like a behavioral psychology perspective, what we kind of learn around incentives is that if we set up, say, you mentioned kind of a QA group that would look at the development branch or something like that,
Hmm.
then naturally people will outsource the responsibility for quality to that other group. And I would argue what we want is the developer to own and be accountable for the quality of their work. When we then layer in continuous delivery on top of it, the incentive that we're creating, and at the beginning of Flow, this was true, and then we'll kind of share how it evolved. The only way you can prevent a bug to show up in production is by writing an automated test. That's it.
Hmm.
It's not going to be gated anywhere. It won't be deployed to a staging environment. Either you write the automated test or you risk introducing a bug in production. And the incentive structure that creates, you can probably guess, but we have incredible automated tests. Incredible. Um,
Yeah.
and that's what we wanted. That was the outcome that we wanted in the company. And why did we want that? It's because we believed in the power of automated tests and the leverage that it gives us over the long term as the company grows. And our developer velocity, I think we were able to maintain as the company grew, as the size of the team grew. But it all came back to why? Because we had these very, very good automated tests. Were they perfect? No, we'll come back to that. But very, very good automated tests. And the incentives were set up such that that's what we as developers did in the company.
Yeah, I mean that part makes sense to me. I've always been a fan of whenever I've gotten to work with QA people. One of the things I've really appreciated about them is that they tend to have a well-honed skill set. Maybe you could say it's because of incentives, but also maybe just in terms of like reps of like finding bugs and like finding problems, before they get out the door. I've never worked somewhere where I felt like, yeah, if QA weren't here, these bugs wouldn't happen. Now, granted, it's possible that if they weren't there, then people would be more careful, would feel more ownership, etc. But I do think there's still some gap there in terms of skill set, about like just skill at finding problems like weird edge cases and hunting them down and so forth. But I do wonder about maybe in the context of the system you're describing, it would be like, yeah, you hire a QA person and their whole job is like trying to find issues and writing automated tests for issues. And they're never testing in any staging environment before things go out the door because they're all about writing automated tests to anticipate future problems or things like that. Does that sound right? I mean, or maybe, I mean, I know
Yeah.
philosophically, some people are like, I just don't believe in QA engineers, which if that's your view, also reasonable, but
No, I
curious what
think
you think.
the only thing I would add to that is that I think QA is a skill like any other. It's just that um, I guess my preference or what I've seen is it's better if that skill gets developed in the people who are responsible for producing the software. They're just in a
Okay.
position of leverage, and that's not to say that there isn't like a different role around integration testing or UI testing. There are areas where it's still very difficult or expensive to write automated tests. And then there is a role for kind of manual testing,
Sure.
100%. But in general, in the areas where it can be automated, again, the leverage, if we can all learn as developers how to write those tests, I think there's incredible leverage there. The
Totally
other
fair. Yeah. And
and
I
the
guess
other thing
go
Actually,
ahead.
the other thing I'll add here is like the types of like most of my career has been building web applications. And within web applications, if we just bifurcate to keep things simple, there's like front end development and back end development, UI and back end development, let's just say.
Yeah.
And what I found fascinating at Guild is it was relatively easy to write very, very good automated tests for the back end.
Hmm.
Like you have very high confidence you're not introducing a regression.
Sure.
Um, to test front end changes, we really struggled. Like we would at
Yeah.
Guild, we would set up staging environments, but the front ends typically talk to lots of different services. So now you're trying to get all these services to actually work in a staging environment. The environments aren't maintained as well as production, so inevitably things break. The software gets big. Now you need to do networking, and that's interesting. And so we end up at Guild, we honestly end up spending about 40% of our overall tech budget just on like QA and managing these staging environments and all that. And guess what? We still had bugs in production. We're still finding bugs in production
Yeah.
even with this massive investment. So really the question was like, is there a better way to deploy that budget around quality, however you define it, to increase the overall quality of the software as we find it in production? And it doesn't mean not testing. In fact, it means a lot of testing, but trying to test in a more productive way where you find things earlier before they impact users.
So did you ever find anything that worked really well for you on the front end like you did on the back end?
What we found, what's really interesting about the front end is a lot of the development is just safe to use directly against production. So um,
Sure.
you can, because a lot of it is read only actually.
Hmm.
So all your read only UIs, if you can point them at a production API and you can build your software so that it's using APIs, you're in like a world of bliss because you just fire up your front end, it's talking to production. Production's up all the time. It's a very stable environment in almost every
Sure.
company that I've ever visited. So it ends up being just kind of like a fantastic environment. The way we actually made that work as Flow matured were kind of standard things. We introduced feature flags in the platform. We were a SaaS platform, so then we allowed developers to create their own accounts in production. An account in production could be labeled either a production account or a sandbox account. sandbox accounts would make sure that things like credit cards would never get charged in the real world.
Right.
I was actually surprised at like how few things we actually had to turn off in Sandbox. It may have just been credit cards. Maybe there was one other external API call that would induce a charge that we wanted to avoid, but it's very, very little.
Yeah.
Um, and then kind of the last area, like and for front end, that was really it. You get your own organization in production, you label it Sandbox, you turn on your UI, you're using production APIs. Guess what? Now you can actually do write actions because those write actions are against a Sandbox org, so you're not going to hurt anything in the real world. Very,
Sure.
very high fidelity, fast UI development. And then again, on the back end, we really relied on these primarily automated tests and feature flags to control the behavior.
And this is actually like the topic of front end and back end gets into part of the reason I bring up QA and also part of the reason that I bring up, I don't know, technology solutions other than services. Because, for example, let's say that you want to make a layout change to like a CSS file that could potentially affect the global layout of like every page.
Yeah.
If you're only testing in production, like how do you commit that change and have confidence that it's not breaking things? I remember on the like, so the Rock compiler code base has a lot of tests, but they're really all about compiler functionality. We don't really have any tests of the like rocklang.org website. And I've been very permissive generally about new contributions as long as the tests are passing and I review the code, or somebody I trust reviews the code and says like, seems reasonable, seems like it's not making the code worse, seems like it's probably correct and the tests are passing, might ask them to add some tests, whatever. The only PRs I can ever remember rejecting are, one, because I'm like, actually, this is not the design we want. And two, this is the design we want, but you're changing a CSS file and I just have no confidence this is going to break the whole website. So like, I'm sorry, I just need you to write this in a different way, because like, I don't want to go re-review the entire website just for the sake of this one little tweak. Like, and actually that PR got closed and somebody else made a PR that was not having to change like global CSS. And I was like, okay, sure, accept it. And it fixed the same problem in a different way. But obviously that doesn't work for every UI change. So I'm wondering if, given that you can't solve that with microservices or any kind of like server-based architecture, like what tricks did you end up finding that did help with the, you're still testing it against production, but you have some sort of layout change that might affect every page theoretically. How do you make sure it doesn't break everything without like retesting the whole world every time?
And this makes me think just about production in general. And like where we want to end up is we want to be very, very efficient in production and understand how production works.
Yeah.
And when there's an issue in production in particular, we want to be able to restore functionality as quickly as possible.
Yeah.
And so like with that mindset, when I start thinking about a big change like this, I start thinking about how do we get that inside of a feature flag somehow. And maybe it'll be more work in the development process. But the reason we want that is we want to be able to deploy the change to production off and then have some way to control who's actually seeing it, whether it's a group of users, maybe it's a kind of a SaaS account, maybe it's a sandbox account. And more than that, as we kind of start to think about now we're getting ready to roll this feature out, like what does a good feature rollout look like? A good feature rollout looks like enabling that functionality for a very small percentage of the traffic.
Yeah.
And then slowly measuring, quickly measuring, but slowly over time, kind of increasing the amount of traffic such that we're confident in the metrics that we're seeing. That doesn't guarantee that we're not going to learn something late, but if we do, we should be able to revert that within seconds in production.
Got it. So in the example of like a layout change that could potentially affect every page, you might say like that layout change is going to be behind a feature flag, and therefore we're going to deploy it straight to production, like PR to main, that PR lasts for less than 24 hours, ships straight to production. However, in order to see the new layout, you have to flip a feature flag. And so now whoever wants to QA it, whether that's a dedicated QA team or engineers who have been spending proportionally more of their time and skill set on QA, they can go through and do that. They're just doing it in production rather than in development.
Yeah, and another way, like I would say, we start to think about production is less like the production network or the production AWS account, like the core infrastructure. It's less that, but really production is like where our users are interacting with our software.
Yeah.
And that's really what we're optimizing for. Like, how do we make sure that our users are going to have the best possible experience? And what's really interesting, even in this example that we just gave, one of my favorite problems that happens is bug in production, and the team says, "But it was working in test."
Yeah.
Well, now we're verifying it in the target environment, which is production, and that whole category of bugs just goes away. It can't happen. It wasn't.
Right.
It's only verified in production. We've eliminated a whole class of kind of very difficult problems to debug.
Yeah, it's funny. I mean, I was thinking back about what you were saying about incentives, and I'm reminded by another thing that we do in the Rock compiler, which because we don't have a numbered version yet, we're still pre O.1 technically, even though we've been working on it for a couple of years now. We do have nightly builds, and so when people come to try out Rock, they just try out the latest nightly build. Well, this actually turns out to have a lot in common with what you're describing in terms of like always working in production, because every time you merge something and land it, it's going to go out in the next nightly, which means that end users are going to interact with that code that you just merged immediately. And so if you broke something, you're going to hear about it the next time a beginner, fires up they just downloaded Rock and they show up like, hey, this didn't work. I thought I'm going through the tutorial and whatever happened. So we're always mindful of that. And so that means we sort of naturally exercise the muscle more of doing things like, if we're going to introduce something new, we think about, is this a breaking API change? Is this going to break the tutorial in any way? Do we need to put this behind an environment variable or a CLI flag or something, maybe with a -- experimental in front of it? And that's kind of the equivalent of the feature flags that you're talking about. Or in some cases, we will take care to say, okay, can this be we introduce a new thing and we sort of silently deprecate the old one, where like it still works, but the formatter rewrites it to the new one, which is kind of like doing a schema migration in production in some sense. We've done that with syntax a number of times. There's still some like ancient Rock syntax from like, a year ago that like we already moved away from, but the parser still accepts it. And then the formatter rewrites it to the new thing, just because when the person made the new syntax, that's just what they habitually did in the PR, because we always do that. And when you say it that way, like, yeah, I mean, that has worked out really well from an incentives perspective. And I don't see any reason why that couldn't become more of a norm in software communities. But again, to your point, I guess I have a hard time imagining it becoming a norm if you still have the firewall of a staging environment, as opposed to quote unquote staging being in practice production with a certain set of feature flags enabled.
Yeah, and one thing I'll say is like when you start deploying something behind a feature flag, it also starts to incent people to verify that nothing changed. So if we go back to the CSS example, as soon as you deploy the new version that has both CSS style sheets in there, the thing to do once you deploy is to make sure the old CSS is showing up.
Right.
And that actually is also like a really good practice for quality software. It's like first verify the things that you didn't expect to change are the same.
Yeah.
It's easy for us to think about verifying the new feature because that's where our mind is. But step one is no change in existing behavior.
Yeah.
The other story, somehow you triggered this memory. I remember I was really young in my career and we were growing Guilt and having a very difficult time because our traffic had ramped so rapidly. And I was lucky enough to have kind of an incredible engineer join us. And he wrote some software that was responsible for inventory management, making sure we don't sell the same shirt twice. If we only have one, you sell it once. And I still remember the day we deployed this to production, the next night, guess what? We sold like, 10,000 things, but one of those things got oversold by one unit.
Okay.
And so we have a bug.
Yeah.
And so he and I remember we got into a conference room together and we're starting to crawl through the logs in production. And he had instrumented his software sufficiently such that he was able, I would say we, I was watching, he was able to recreate and prove definitively what had happened in production that led to that bug. And I remember just being in awe.
So he was able to do that without looking at the real logs of what happened,
Real
or
logs, but he had logged enough information in production
I see.
to be able to prove definitively like what was the circumstance of that particular bug. And as soon as he had that understanding, he fixed the bug in like 5 minutes. That's easy. But it was like once and done. And I remember just absorbing, like watching him at work. And I guess the lesson that I took away from it was just like almost like treat production with the idea that there will be failure nonstop. And then as we're producing the software, like do everything we can to learn to leave behind hints for us when things happen so that we can maximize the time to recovery, and just keep like, I guess, ultimately like drive the quality up for our users. But what's amazing is like he was doing this in production. He was logging in production. He was looking at the logs in production. Every time he deployed software to production, he was tailing all the logs. He was looking at all the instrumentation. He was making sure that there wasn't anything that he missed, but he was going in with the idea that he's going to miss something. And he's going to just work his tail off after every deploy to convince himself that actually no, he didn't miss anything. And that's like a little bit of the maturity. Like when I think about kind of testing in production, sounds a little bit glib, but it's really the opposite. It's like production is the most important environment for our users, and let's use all of the possible tools that we can to increase what we see, how we see it, how quickly we'll be notified, and just try to reduce the number of kind of these defects or issues that actually get out and affect our users.
Yeah, this reminds me in some ways of what Dan Liu talks about when he talks about working for hardware companies before he got into software, and how the testing process and like the tooling and investments and the type of things that people make, a lot of it is about simultaneously trying to prevent failures as much as possible, because it's really, really expensive to fix a bug in a physical chip because you have to go remanufacture the whole
Yeah.
thing, and this is just a really, really different scale of what that costs. So you want to be really careful up front, which reminds me of your spending several months of this brand new startup just setting up automation to make this possible. But then also, because it's hardware, that some things are going to fail. So they're also making a big investment in saying, let's assume that this part could fail, or that part could fail, or both of them could fail. What do we do if that happens? And obviously, their mitigations in hardware are going to be different than your mitigations. But I'm kind of curious what specific tooling you've sort of settled on to do that, because I've heard a lot about, especially with like the term observability, there's a lot of talks about like logs versus tracing, spans, and there's just a lot of different ways you can go about the sort of category of instrumenting what's going on in production and helping yourself understand it. Certainly, based on your story there, it sounded like you have good observability in the sense that he was able to answer the question of like, how did this bug occur? Without like definitively, like you said, not just like, well, here's my theory about what happened. It's like, no, this for sure has to have been what happened. I can see exactly the line of what sequence of events occurred. So I'm wondering, like, what do you remember what those specific tools were? Like what he had instrumented, how he instrumented it?
Uh, so in his particular case, it was, I still remember the piece of software. It was actually a very small application. At the end of the day, it was like 3 or 5,000 lines of Java, but it like managed all inventory for Guilt.com. I remember we peaked at, I think our peak was 2 to 3,000 requests per second back in 2008 for a
Mm-hmm.
single piece of inventory. It was a heavily discounted automobile that people really wanted,
Okay.
and it
Wow.
all worked. But ultimately, it was an in-memory representation of all of the inventory, and the core data model was a hash map with locking around the SKU and the specific number of units of inventory. And
Okay.
knowing as he went in, he understood from the design that that was kind of the core part of the design. And therefore, every access to that data structure had logging before and after every
Mm.
entry, if I remember. And through that, he was able to see kind of like a unique identifier get repeated, which is what gave him
Okay.
kind of the hint.
So this was
I think
pretty ordinary
ordinary.
infrastructure. It's just like just log every time, just like here's what it was before, here's what it was after.
Yeah. I would say if you, a pattern would be like verbose logging. And it came from this like, I'm going to assume this is going to break. And when it breaks, I need all the information possible.
Okay.
And I think that strategy, that I mean, it was to me, it was like just it's a great strategy. And maybe over time you can start to optimize. We want to pay less on logging, and so we can reduce the verbosity of the logging. But I would claim we do that once the system is stable for a long period of time.
Got it. Okay. And this was around like um really important. So I guess you just use your judgment to decide like what to log and what not to log. It sounds like you didn't really have any necessarily any automation, like for example, saying every single time somebody hits the database, we're going to log that. That's like a manual thing. You say like this database entry seems important, this one doesn't, or you just, are there certain things that you always log as a matter of course with where there is no judgment call? Or
I think judgment. I think a lot of what we do in software has a lot of judgment built into it.
sure.
And for my own career, I've made thousands of errors, like thousands. I've like to my users, I'm sorry, but like every day I just try to get better. Is
Sure.
kind of and I think judgment is a bit part of is part of that. It's not that we're perfect, no one's perfect, but that we're continuously learning and just trying to improve kind of our craft, our art. Um, I think that's actually a big part of it. And back to kind of incentives, when I think developers have the accountability for is their app running well? Are there defects in production? What ends up happening is we also then are much more open to learning when things don't go exactly as we planned.
Yeah.
Um, where I think the as a company, in order to make like all of this work, um, the things that we really in my career have really invested in is like how can we detect quickly that something isn't working, and how can we restore service as quickly as possible. And the other element, kind of maybe to mention around just operational maturity that we introduced over time at Flow and at Guilt, was that as you're kind of releasing all of this software, like what is there a metric that you can count? Is there something that you can measure automatically that will give you some inclination that things are trending correctly or not? And for my background, I was kind of influenced by maybe 20 years ago. We were an Akamai customer, and there was a brief outage on Akamai. And Akamai, I think, has one of the most stellar track records in terms of uptime of kind of any web software built. They're incredible. And I was able to read their postmortem on their outage. And the postmortem basically went something like code was complete, tested, verified, deployment started. We started deployment in one of our points of presence on one of the nodes in that data center. Over 30 minutes, we measured that node, and there was no noticeable change in successful requests versus unsuccessful requests. So then we expanded the deployment of that software to the other servers in that point of presence. I think they had 60,000 points of presence at this time. So we're talking about one out of 60,000. We let that software run for 2 hours, measured, looked good. At that point, we started initiating a rollout across whatever, North America. 2 hours into the rollout, it turns out that there was a slow memory leak that had caused those instances to start crashing. That
Mm.
was automatically detected, and we immediately initiated a rollback. That rollback took another 20 or 30 minutes to complete, at which point service was fully restored. And I was like, wow, that's amazing. Like, why isn't all software released with this level of like automation and instrumentation? And for me, that's been the target ever since. It's like, how do we get to that point where we have that automation and we are measuring?
Interesting. So, yeah, okay. So, being able to automatically detect not only problems in advance via testing, but also more so than is the norm, I guess. Like basically more than just like the pager goes off because like prod is 500ing, more than just health checks, but like having heuristics around what normal service looks like. And obviously for gigantic companies, it makes sense to make those investments, but it sounds like those are the types of investments that you think smaller companies should be making more than they are, smaller teams.
Yeah, and I would say back to, if we're not spending 40% of our budget on maintaining staging environments, then we
Mm.
can take some of that budget and invest it in better operational maturity earlier. And I would argue that that has way more leverage because not only are you getting that during kind of the development process, but you're getting the benefit in production long term. Um,
Yeah, so really, I mean, if I could summarize like another way of saying what you're advocating for, and this, what you're talking about resonates a lot more with me than the traditional pitch for microservices, because when I hear that, the traditional pitch for me, it's like, make the services small because of Conway's law, and your teams are going to end up, reflecting your org chart. Your code base is going to end up reflecting your org chart anyway. And I'm like, yeah, but why can't there be modules? They don't have network latencies and like, all the problems with the network and new error cases and yada yada. You have a distributed system when before you didn't have to. But really, what your pitch is more like, incentives are real, and I have not seen modules successfully overcome the incentive problems, which isn't to say that it's not possible, but to say that it's worth trying something else, which makes sense to me. But more of that, it sounds like you're making a really strong pitch for people are dramatically under investing in automation. Like the idea, if you listen to traditional startup wisdom, like I've never gone through Y Combinator, but I've heard, from people who have, and also from their writings about it, that it's like the first like 3 or whatever months of Y Combinator leading up to their big demo day presentation, what they tell every startup to do is do nothing but write code, like build features and talk to your customers and like exercise. That's it. And like really they're saying don't waste time on anything else, which they're implying don't invest in things. Basically, they're saying like just ship features, talk to customers, and that's it. Obviously, they have an extremely strong track record of leading to successful startups, but that's extremely counter to what you did. You basically said like, no, I'm going to spend the first few months making investments that I know are good investments, in automation, in tooling, in instrumentation, and all these things, because you've seen them pay off even at the scale of a brand new startup. And like you said, that's how you know how to ship software effectively. So you're like, I'm going to do whatever it takes to get in that position where I can just fly and have things work and deliver software quickly. Um, all of which is a roundabout way of asking, what did you actually specifically build in those few months? Like what was the sort of set of automation and tools and infrastructure and all that that led you to the point where you're like, cool, now I'm ready to build stuff?
So when we started Flow, we knew what we were doing is we were going to help brands sell internationally. It was something that we did at Guilt. It was hard. So we're going to build a platform to make it easy for brands to sell to customers in other countries. And we knew it was going to be an API platform to make it embeddable and pluggable to some of our larger customer use cases. And so early on, and I should say at Guilt, we started a open source project called API Builder, which initially started off as like documentation for different APIs.
Hmm.
Where we saw adoption within the company was very, very good code generation at building client libraries to access APIs from any platform. And back then, it's like the iPhone came out, then you needed Android, then you needed Swift and all this stuff. And so developers were spending a lot of time just writing integrations to REST APIs.
Yeah.
So we built kind of a very, very high quality code generator to kind of replace that. As part of that, so like within Flow now, we needed a developer process for managing APIs. That was something that we needed to do well.
Yeah.
When back to the kind of microservices and where kind of boundaries end, the way that we actually learn to enforce that is we use code generation from the spec of the API, and we use code generation everywhere. Like initially, it was like, here is the client that you can use in your automated unit tests or integration tests to
Mm-hmm.
make sure that you're doing all the things right.
Yeah.
And so building kind of writing those code generators in the style of the kind of early services that we wanted to write was something that we did early because we wanted to make sure that our APIs were kind of fully tested. So that was like one big investment. And probably the second was just how we deploy our software. And kind of the idea there was we started in AWS, but didn't want a human to touch AWS. So like automate everything so you can deploy a new service into AWS with whatever resources it needed from a
Ah.
command line. Um,
Okay.
and so we built a little CLI, and you can do like dev bootstrap. I forget what the command was, and it would or set up all the scaffolding you need in AWS to be able to release one of these services. And that ended up being a big point of leverage because ultimately, what happened as the company grew, we would get people who were kind of experts in, say, database technology.
Yeah.
And now you're spinning up a new microservice. Well, they would be the ones who would set kind of the template for what kind of databases other teams could spin up. And over time, what I've kind of come to appreciate is kind of this style of automation meant that the experts in each part of our stack would form kind of the perspective as to what's best for the company. And in
Mhm.
almost all cases, dev teams would just adopt it. Why? Because like they're the experts. This works. This is what works for us. And it became kind of a huge point at enforcing um, conventions within across the company. But those are basically the two. Like, how do you set up all your AWS infrastructure? How do you deploy? And how do you do code generation for all your APIs to make sure that we can write consistent tests?
That reminds me of one of the points you made that I thought was really interesting. And I forget if this was we were in talking in person or in the talk you gave that went viral that has like 750,000 views or something like that. Where you basically made the point that you sort of argued against one of the traditional selling points of microservices, which like this team can use Python and this team can use JavaScript and this team can use Scala and everybody can just do whatever they want and not bother each other because everybody's speaking some common, JSON or whatever to each other. And your point was like, don't do that.
Yeah.
If I could summarize it.
Yeah, I'm a huge fan of microservices. I think they have tons and tons of benefits. As we were learning microservices at Guild, we allowed ourselves to have flexibility in the programming languages that we use and the tools we use in each service. And I will say that I think in hindsight was a mistake.
Mhm.
And so when we started Flow, we have kind of an engineering principle, which is one way of doing things, period. It's somewhat a hurdle to introduce new technology at Flow, which again, pros and cons and everything.
Yeah.
But the thinking behind it is like software is hard. Like building and operating quality software at scale is really, really hard to do. Like let's pick our tools, love our tools, and then really, really learn them, like deeply learn them so we can understand how to scale them. And it takes years. Flow is kind of the core platforms written in Scala. I think it took 5 to 10 years operating Scala to get to a point where like we're reasonably quick at diagnosing issues when they happen.
Yeah.
And that's, and still every year we discover a new issue that we didn't know about that's kind of deep in kind of the technology that we're using. So here the idea is like, let's really lean into kind of a single culture around the technology we use, how we write, share code, and really get good at understanding how it's performing in production. A side benefit is that it's easier for team members to onboard onto the company because you can join any team in the company, learn their way of developing software. And you'll find if you move to another team, yes, you have to learn the domain, but you don't have to learn the technology or the approach because the tooling's the same, software is written in the same way, tests are written in the same way, everything is deployed in the same way. And like that overhead goes away. And then as a developer in our company, you're working on the one thing we care about most, getting like really good functionality in the hands of our users so our users could be successful so that our company could be successful.
Yeah. And that makes a lot of sense. I mean, I think there is still an element of like you said, there's pros and cons. And obviously, if you aim for like being technologically homogenous, then eventually that over time will necessarily lead you to become technologically obsolete because new stuff comes out and you're like, we're not going to use it. We're going to stick with what we do. Just definitionally, that'll happen. But of course, that's not the same thing. It's not like the only alternatives are that or anything goes, do whatever you want. I'm reminded of, you mentioned like it's not just about language, but it's also about style. And as a Scala developer, I'm sure you can appreciate this because Scala, along with JavaScript, are two languages that I would put in sort of the top tier of variety of styles that are used within that language. Like Scala has, I guess, like the big three that I've heard of are like Scala as sort of Java++, where you're just using it in basically a Java style, but using some of Scala's additional features, but not really changing things up from a traditional object-oriented Java style. Then there's on the opposite end, there's Scala as Haskell on the JVM, basically, like just going maximum monads, out the wazoo. And then somewhere in the middle, there's Scala as sort of Odersky intended, perhaps as a intentionally hybrid OOFP language, which is yet a third style. And then even within each of those, there's like different there's like cats versus, ZIO or whatever. Now we're getting out of my depth, but I think that's an interesting point. Is that it's not just about like language and trying to enforce that. Which I think when we talked, or if it was in that talk, you mentioned like there's a tooling downside there. Like if you're investing in automation and you're doing something like a code generator, like you talked about for your APIs. That's something where you now have to do that n times for each of the n different languages you're supporting because they all have different code to generate, unless you're going to say, well, the tooling is more important. So we're going to say everybody uses the same language and now our code generator, everyone can use that. And now that just becomes part of our normal development. So in a weird way, it's like your approach to microservices is again different from the traditional thing that I've heard, where you're giving teams autonomy in some things, such as deployments and ownership of the code, and being responsible for their changes, but not in others, such as you're not giving teams autonomy to say use whatever tool you want, use whatever stack you want. You're like, no, here's the tooling we're going to give you. In a lot of cases, you're not going to dictate, but you're going to strongly suggest here's the database style you should use, and things like that. And that's really interesting because that's again not something I really hear, at least not at the same time as microservices. And even just on the point of code generation alone, that's pretty controversial. A lot of people will say code generation is a mistake. Here's the laundry list of reasons you shouldn't do it. But it sounds like you're just like, no, we should do code generation, and you've had a good experience with it.
Yeah, and when I was early in my career, I worked at a company where we had quite a bit of code generation, and kind of I formed that opinion myself. Code generation is bad.
Okay.
Now, kind of I guess experienced enough to know that everything has pros and cons, and one of the things, the way we use code generation at Flow, which has been incredibly successful, is we use code generation and we never modify it. It's not scaffolding. You don't touch it. It's code. It really is code generation, and you use it. And that's been a really powerful point of leverage. And in the talk you mentioned, which maybe we can link to in the show notes, one of the examples I gave is like, one of the things I dislike about debugging production database access is like, why is this query slow? Oh, it's because we're accessing a column that didn't get indexed.
Right.
Well, it turns out that if you use a really simple thing to do with code generation is you just provide methods to access the data through the columns that are indexed.
Mm-hmm.
And then you're not going to have that problem in production.
Right. Like if it's not indexed, you cannot include it in your query. Yeah.
You can work around it, but you're gonna, you're gonna go off the beaten path, and you're gonna know you're doing something weird. So like you can just do all these things that have like all this value, and somebody new to the company may not initially appreciate why it's that way, but it's that way because you've learned to avoid a problem that's going to hit your users in production. And again, that's what we really, really optimize for.
Yeah.
Um,
So like one of the many things that you're using automation for is to create pits of success around really common things like that.
yeah, and ultimately, where we've used code generation is once as a company we see people doing redundant work or work that looks very similar, and we have multiple examples of it. Like those are the opportunities where maybe there's an opportunity for code generation or not.
Hmm.
And I'm a big proponent of that. Like very early on, we would just copy code as we were growing the business. We weren't too worried. We weren't dogmatic about don't repeat yourself or anything like that. And in many cases, I always just personally find it sometimes simpler to have similar code that you can just step through versus more complex code with lots of parameters on how it behaves.
Hmm.
But ultimately, we had these kind of redundant patterns. That was just an opportunity to say, hey, would there be benefit now of standardizing the way that we approach this as a team, and then applying some code generation around it to save some time.
Now, I've heard some people make the case that if you're using code generation in the way you just described, where you're like generate it and then never touch it, that suggests that you should be using a macro. But is that just because the language you're using, which I don't remember if it was Scala or Ruby at that company? Um, was it that it didn't have macros, or was that you think that code generation has separate value even if you do have macros?
Yeah, I would say I've like personally never found an opportunity to use macros where I didn't regret it. Um,
Interesting.
yeah, I just macros for me are just they go a little too far down the magical path. Like one thing, just coming back, like when you code generate something, the code is sitting right there.
Hmm.
So you can look at it in your editor, you can step into it in your editor. There is like zero magic going on. There's no question about when the code is actually kind of created. And kind of
You
that
check it in.
yeah, it's checked in. It's checked in. It's part of the source tree. Period. And I just thought that accessibility of like it just happens to be code that somebody else wrote for you, and you can look at it. All your other tooling works around it. There's nothing you have to learn. Like keeping that hurdle low, I just find like super valuable.
So it's like it's a macro where you're always able to look at the macro expanded form anytime, trivially, and also you can tell if the when the macro changes, you can see like what the implications of that are because all of the source files,
Yeah.
their diffs all change. And I guess
And
also that is to some extent a potential form of versioning in the sense that if you decide to change the code gen tool, you don't have to rerun it to regenerate all the old ones if you don't want to. You could just say, from now on, it works this way, but the old ones we're going to leave working exactly the way that they are, and therefore reduce the chances of a production breakage, I guess.
yeah, I would say where we saw real value is like if there was a bug in the code generated code, like it's really trivial to fix and get your product to ship.
Sure.
You don't have to wait for the code generator to get fixed. You can locally fix it and then iterate on the code generator and then move on through your world. And that's like super helpful. It's much easier to do that than to debug a macro for most developers.
Great point. Yeah.
The other just practice that we introduced at Flow, which was super successful, we called it Dependence Day. And basically, once a week, we updated all the dependencies of all the microservices and all the generated code. Like we just every week.
Wow.
Um, and the rule was, and we had some decent automation around it, but it opened up PR. As PR goes green, you merge it, it's going to production. And that was like our own libraries, open source libraries, everything just got updated. And it's like amazing. And the reason we could do it is because we had so much confidence in our automated tests that if the tests pass with your upgraded dependencies, you're on your way to production. So
Now,
it's
this
almost the
wasn't front
opposite.
end dependencies, I'm guessing.
Front end was different. Front end we had
Okay.
more QA around front end. Yeah. Back to you need the kind of we didn't find a good way, or the cost of automating all of that just never seemed worth it to us at this
Yeah.
time.
Did you ever do any like screenshot tests for front end or anything like that?
We dabbled with it, and it's been a long time, so I don't have any recent experience in the last 5 years. But what I recall from our experience is just the time spent maintaining the tests and dissecting the false positive. Just it kind of people got frustrated and just said, let's just look at it as humans and do
Yeah.
it that way.
Now I know you've gotten into Elm since successfully exiting both of those companies. So I'm really curious to hear what your thoughts are in terms of like a lot of people would say, if I'm starting a company right now, I'm going to use JavaScript and React because that's kind of the industry standard, or TypeScript and React, I should say. That's the industry standard. That's what everybody knows. Now I know that you've been using Elm on like personal projects, but I'm kind of curious to hear your thoughts on like this is a technology that's outside the mainstream, but you're obviously enjoying it. How does this fit in with your, like, if you were to start another company tomorrow, what would you think about using Elm for that?
So I learned about Elm from you on one of your earlier shows, and I just
Nice.
want to thank you for that. Elm is
Cool.
amazing. Everyone should be using Elm. I won't write any web front end outside of Elm ever again until something better comes along. Like it's just so good, so good.
I agree.
Yeah.
No argument
Um,
here.
and one of my personal side projects was I wanted to learn React many years ago, and so I wrote a little app in React and kind of enjoyed it. And it was a really pretty app and got up and running. And then about a year later, I came back to it, and enough of the dependencies had changed that I could no longer deploy my app to production.
Oh no.
And I'm just not smart enough to figure out what to do with it. I actually hired three consultants who are like expert in React, and two of them said at this point you might as well rewrite it. And
Wow.
I was like, oh my god, what is going on in this world? And so obviously the answer is rewrite the thing in Elm, and everything that I've written in Elm in the last, I don't know, 12 to 18 months, all of it works. I don't have to debug anything in the browser. I don't get any exceptions in production. It's like remarkable. It's so good.
I keep telling people this. It's like I made this prediction. I forget when I said it. And maybe I should have made it more publicly, but I was like, I don't care what comes out in the React TypeScript ecosystem in the next 5 years. Elm's still going to be the best. You know how I know that? Because the foundation is just what makes it so great. Like, even if Elm doesn't have an entire release for the next 5 years, it's still going to be better than whatever the latest and greatest is in the React TypeScript world, because the foundation just cannot be fixed. Like, it's
Yeah.
this whole, it's like built on quicksand. And it's like, it's constantly shifting. And like, yeah, it's just not, I don't know how to communicate it to people who haven't tried it, but yeah, it's really, the gap is really large.
Yeah, and it's interesting. We were talking about Scala and code convention a little bit, but like at the end of the day, just like a purely functional language with no side effects, like the value of that is immense. And then when you add in a compiler with a good type checker, like that value is incredible. Um, and it's just
Yeah,
yeah, it's been a real pleasure. I really enjoy working with Elm. Fantastic. I
that's
do. It
awesome.
does beg the question, like why so few people get exposed to functional programming generally, and like what we can do to increase that. But
Oh
it does
man.
seem
I
like
mean,
once you cross the bridge, there's no going back.
yeah, I mean that's a deep topic, and one I've certainly thought a lot about. And I mean, unfortunately, there's no one answer to it. I think anybody who says they've got the one sentence answer for why functional programming, it has not become the norm, or like doesn't catch on the way that a lot of people are like. There's a pretty big gap between people who've spent significant time with like a language like Elm, and like their understanding of how popular it should be. And then like everybody else is like, well, of course that thing's not popular. um, but yeah, the explanation for that gap is, I don't think, simple. I don't think there is like one concise explanation for it. It's a lot of different factors. Like, the more I've learned about it, the more I've concluded that there isn't one explanation.
Yeah, that
um,
sounds right.
but at the same time, I mean, I think the same could be said of a lot of the things that you've described over the course of this episode. Like, the investments in automation that you make, I think it'd be really easy for someone to try out like working in that environment and be like, this is awesome. This is what everyone should be doing. Why isn't everyone doing this? And everyone else, and a lot of other people, to say, because I don't want to spend the first couple months of my brand new startup in, making investments that might not pay off. Because that's, to them, that seems risky. But to you, it doesn't seem risky because you've had the experience. You're like, no, this is awesome. This is great. I don't want to build stuff any other way than this from now on. But that experience is not universal, unfortunately.
I wonder if we'll never know this because we don't know what would have happened. But I believe that we got our MVP out faster, even with the initial investment. Because at the end
Yeah.
of the day, we know we're going to be producing software. We know we have to get it running in production. Um, and then over time, the real benefit came, I think, as the company started to really scale.
Yeah.
And I mean, we were able to like swap out the backend databases on everything in like 3 weeks. We were able to go from Java 8 to Java 17, 2 people, 10 days. The entire company moved. I mean, it's just we were able to do these like remarkable things that like would never have been possible or have been like multi-year projects, and they were just there because of like the consistency and the automation. It was just like amazing part of the company.
Wow. Yeah. That's a lot of cool stuff. Yeah, I mean, one of the recurring themes of, I guess, between both Elm and some of the things you were talking about in terms of like automation and tests that you set up ahead of time, and I guess like tripwires that you set up after the fact, like to detect things in production, like the inventory. You should never sell the same thing more than once. Those all get into that theme of like invariants, or I like to say guarantees because it has sort of like a baked in positive connotation to it. Um, but I guess that's something that at the beginning of my career I had not a lot of appreciation for. I didn't think that that was like a big deal. I thought like, well, everybody makes mistakes, there's exceptions to everything. And I don't know though, like as I spent more and more time, what I kind of realized that if you have an invariant or you have a guarantee, it reduces the amount of things that you have to keep in your head, because you're like, well, I don't have to worry about this, I don't have to worry about that, or I can rule out this explanation or that explanation because I have an invariant around that I trust. And when that's the case, it seems like a lot of things get done faster and are easier to work with and easier to keep in my head, because what I can keep in my head more often than not seems to be ultimately one of the main constriction factors on like what I'm able to accomplish. But I don't know, like it sounds like you feel the same about a lot of that.
Yeah, I mean, I would take it even further. Like, I find it really difficult to throw myself into the next problem if I have some uncertainty or some questions about the last one I worked on.
Hmm.
So I really like to finish things. Um,
Yeah.
and actually, it reminds me at Guilt, one of the fun things we did as a technical engineering culture was we celebrated when products were removed from production.
Yeah.
And in that context, it's like there's a big difference between like software being 99% gone and 100% gone. It's like
Right.
100% gone. You don't have to think about it anymore. We used to do these big like funeral ceremonies with flowers. We had people who would do breakdancing to commemorate like pieces of software that had, obviously done a lot of good for the company, but were no longer needed going forward. I mean, when we got
Yeah.
them entirely out to keep slimming down the production software, we did these ceremonies. And to a certain extent, for me, it's the same thing with invariants. It's like, if we use a simple example, let's say we're writing a job system and we want to make sure that every job gets tried within 60 seconds.
Yeah.
Like, that's a very simple concept to express. It's a very simple thing to measure. And if you knew that if that ever wasn't the case, you would get notified about that, then you can stop thinking about it.
Yeah.
And to a certain extent, I've kind of like probably late in my career, I've really learned kind of the power of these invariants. And today, as we build systems, we layer in lots and lots of these like invariants or truths, and we define them as like things that we expect to be true about the system. Most of the time, those are simple to measure. If they're not simple to measure, we go back and redesign the system until they are simple to measure. And then as part of kind of like the initial deployment, we really kind of, that's one of the ways that we can prove that the system is working as we expect. And then interestingly, when we learn things, maybe something was a little bit different in the future, again, that kind of refines our understanding of how the system is actually behaving in the real world. And there again, we can refine invariants, add new invariants, fix bugs, whatever it takes. But ultimately, then we have the confidence. It's like running as we expect, and then that gives us kind of the bandwidth to go fully focus on the next thing. And interestingly, a team I worked on very recently, where we were actually handling money transactions, some mistakes were going to cause pain.
Hmm.
Once we ran through and put in place, I think we had over 200 invariants running every hour on all of the data, all of the edge cases, everything. Like, the stress level in the team just dropped, just went away, gone.
Yeah.
We really feel confident now. Things are being measured all the time, and we'll know if anything is not as we expect. Okay, let's go work on the next thing.
Yeah, and I think the Akamai example you gave from earlier is like even more so, where they had an entire I guess it was an outage, like briefly, where everything was detected and fixed in an automated way, where they had a detection that there was like the memory usage patterns were looking bad. It automatically rolled them back even after they'd like done a staged rollout, also automatically. And then at the end, it almost feels like they could have auto-generated the post-mortem, in the sense that it's like, yeah, I mean, here's how it got rolled out. Not everything was fine. Abnormal memory usage patterns were detected. A rollback was initiated automatically. It took this long. All of that is completely automatable. And I mean, if somebody did write it up by hand, all they would have had to do is take that out of the logs, I guess.
Yeah, and in some cases, just to make it really simple, for a lot of the web apps we write, there's just counting the status codes we get back, like percentage of 2xx versus anything else.
Yeah.
Usually is a pretty good starting point for most web apps. Not perfect, but it's usually a pretty good starting point. And then building in the maturity to say, a lot of people are doing blue-green deploys. That's becoming pretty standard.
Hmm.
They're now comparing those percentages across blue-green before you promote to your users. even that incremental step, pretty simple to do these days, huge value in terms of just being able to automate and probably prevent issues from reaching your users.
Yeah, ratchets are a good invariant I remember liking in past jobs where you're like, for example, you've deprecated something and you're trying to get rid of it. Um, Instead of just all or nothing saying like, we're going to sit down and remove this whole thing until it's gone, or saying, well, it's still around, but please don't use it. Basically saying like, there are N usages of this in the code base, and every CI pass, you count how many there are. If that number goes up, then fail the build. And if that number goes down, fail the build and say, hey, good job. Now lower this number and check it in, because from now on, that's the new number. So it can only ever go down. That's the invariant. And then eventually, yeah, you get it small enough. You're like, why don't we just get rid of the last ones? Then we don't have to keep having this CI check, and, and you have a party. I remember shout out to Tessa Kelly. She when I worked at NoRed Inc., she came up with this amazing emoji that we used to put on things whenever we had deleted something, which was, it was a skull but with like heart emojis for eyes, because it was like, we love that we deleted this.
100%.
Yeah.
You remind me, I read an article once about the software inside the space shuttles, and they actually had a target number of defects per release that they had to hit, because they had learned like each release of software historically has 50 or 70 bugs. So if you're going through a release process and you've identified 20, well, you got 30 more to find before you can prove that your software is of quality.
Oh, wow. So the idea was not that we're trying to create more bugs, but rather that like, we assume that we have missed some, we need to keep looking harder.
Right. And I just like that practice has always stayed with me. Is like, that's really cool. It's like, we know how we behaved in the past. Probably, all things being equal, that's a good starting point.
Now, that is, on the one hand, that is cool. On the other hand, I recently learned about an incentive problem. I forget what it's called, but something along the lines of like the Cobra problem. Have you heard about this?
I have not.
So this was back, I don't remember where it was, but it was some place where they had a cobra problem, like the snakes, like wild cobras, venomous snakes. They were a big problem locally. And somebody came up with the idea of, let's create an incentive for people to get rid of these cobras and sort of distribute the solution amongst the population. And so they said, for every dead cobra you bring me, I'll give you a payout. And at first this worked really well, and people were finding the cobras and killing them and bringing them in. And then some people realized, hey, the payout is so good that actually if I breed cobras and kill them and bring them in, I can make a good profit doing this. Once they realized that they were doing this, they're like, all right, forget it. We're going to scrap that whole program. That's the end of it. At which point, all the cobra breeders said, well, I don't want to keep maintaining my cobras. So they just let them loose. And then they had a worse cobra problem than they originally started out with, which when it comes to defects and space shuttles, you can imagine that's not an incentive structure you want to replicate, ideally.
I like how we've come back to incentives. And I think there's a name for what you're describing. It's like initially the thing we measure is really important, and then it gets discovered and gamed, and then
it's a law. It's Goodhart's law or something like that. I forget what it is, but yeah, it's it's definitely a potential problem. But it sounds like in the case of the space shuttle, fortunately the people were involved like follow the incentive the way you would want them to. I hope.
I think they did.
Nice. Well, Mike, thanks so much for talking to me about all these things. This is a great conversation.
Likewise, Richard. Always nice to see you, and thank you very much for having me on the show.
Yeah, thanks. That's it for this episode. I hope you liked it. I put links to some of the things Mike and I talked about in the description. By the way, if you've been enjoying these episodes and you'd like to support the show on Patreon, check out patreon.com/softwareunscripted. Until next time.